Back to Worms Maths Academy. We're about to go through 2016 exam 2, the extended response. In all questions where a numerical answer is required, an exact value must be given unless otherwise specified. So unless it says decimal places, you must give an exact answer. When more than one mark is available, appropriate working must be shown. It's kind of stupid because I know the types of questions they're putting in now. Okay, first one, find the period. Actually, the first thing you should always do is define your function. So 2 cos x on 2 plus pi. So I get rid of what we had before. 2 cos x on 2 plus pi. Define it as f of x. Make sure it's right. Okay. The period, it's 2 pi on a half. So our period, 2 pi and a half is 4 pi. And our range, our center is pi, and we add 2 and subtract 2. So we can say f of x is an element of pi minus 2, pi plus 2. State the rule of the derivative function. So d dx f of x negative, so f dash of x negative sine x on 2. Find the equation to the tangent of the graph of f at pi. So interactive calculation line tan line at the point pi, negative x plus 2 pi. It's worth 1 mark, so you just have to give the answer. Find the equations of the tangents to the graph of that. 2 cos x on 2 plus pi. It'll have a gradient of 1. So we want to find when d dx equals 1 and solve between 0 is less than or equal to x, which is less than or equal to 8 pi, 3 pi, 7 pi. So f dash of x equals 1, therefore x equals 3 pi, 7 pi, when x equals 3 pi, when x equals 7 pi. Okay, so we want to find tan line with 3 pi, x minus 2 pi. And here, y equals 5 pi minus x plus 6 pi. What? Find the equations of the tangents of the graph that. 7 pi. I'm like, that's the wrong gradient. So x minus 6 pi, and because I know the gradient has to be 1, I knew I must have stuffed something up. The rule of f dash can be obtained from the rule of f under a transformation t such that. Okay, f dash, so 2 cos x on 2 plus pi can become negative sine x on 2. Okay, so it's not dilated from the y-axis. It is dilated from the x-axis first. So if we dilate it from the x-axis, we've got to dilate it a half, which means that this and this would both be dilated by a half. So we would say a equals a half, and when we let a equal a half, that will bring this graph would become cos x on 2 plus pi on 2. Then we need to move it pi to the left, which means we'd have cos of x plus pi on 2 plus pi on 2. So let's see, if we've got cos of x plus pi on 2, does that equal anything else? It's negative sine of x on 2. So that's negative sine of x on 2. So therefore, b must equal, so if we apply a dilation factor half, so if we said if a is a half and b is negative a half, we would end up with the same graph. Like this would become this. Okay, let's try show it mathematically. So we know, expand that out, x dash is x minus pi, y dash is ay plus b. So x is equal to x plus pi, y is equal to y dash minus b on a. So we put that into we want to transform the original equation and end up with the second equation. Or could we put it into the second equation and then equate coefficients? So if we did this, our second equation is f of x, f dash of x is negative sine x on 2. So if we said ay plus b is equal to negative sine x minus pi on 2, and then negative b, and then we get y is equal to negative 1 on a sine x minus pi on 2 minus b. Okay. So if we want to make that the same as cos of x on 2, 2 cos x on 2 plus pi, forgot to divide that by a as well, so b on a. So if a is, okay, actually from here, sine of x minus pi all on 2, sine of x minus pi all on 2, simplify, negative cos of x on 2. Come back, you stupid thing. Okay, so we can say that this is the same as 1 on a cos of x on 2 minus b on a. And the other equation was f of x is 2 cos x on 2 plus pi. So therefore 1 on a equals 2, So a equals a half. And if a equals a half, minus b on a half is equal to pi. So b is equal to negative pi on 2. There's our working out for it. Find the values of x from there to there, where f of x equals 2 f dash of x plus pi. So f of x equals 2 d dx of f of x plus pi. Solve, and we want it between 8 pi so we can say f of x 2 cos x on 2 plus pi is equal to 2 times negative sine x on 2 plus pi. They cancel. So you want cos of x on 2 is equal to negative sine of x on 2. So tan of x on 2 is equal to negative 1. So that gives us the same thing. And let's see, tan x on 2 equals negative 1. Oh, you stupid thing. That's going to have lost everything. So let's try it. Tan x on 2 equals negative 1. Solve. We'll go from 0 to 8 pi. They're decimal answers. Okay, we wanted the real thing. So do the same thing, interactive, advance, solve, but then we say given 0 is less than or equal to 8 pi. Okay, so 3 pi on 2, 7 pi on 2, 11 pi on 2. X equals 3 pi on 2, 7 pi on 2, 11 pi on 2, and I'm guessing the next one's 15 pi on 2. Because tan are always the same distance apart. Okay, consider that function given that g dash of x is equal to f of x. So negative a third, negative 1/3, x plus 2, I think it was. X minus 1 squared. So I would expand that on my calculator. Negative x cubed plus x minus 2/3. So f of x, negative x cubed on 3 plus x minus 2/3. It's worth 1 mark. So it's kind of stupid because it says you only need to do working for 1 mark. Therefore, g dash of x is equal to negative x cubed on 3 plus x minus 2/3. Therefore, g of x is the integral of negative x cubed on 3 plus minus 2/3 dx, which is negative x to the 4 on 12 plus x squared on 2 minus 2x on 3 plus c. And we know when x equals 0, c equals 1. G of 0 is 1. So 1 equals 0 plus 0 plus 0 plus c. C equals 1. Therefore, g of x is such a waste of time. Plus x squared on 2 minus 2x on 3 plus c. Find the values of x which g of x has a stationary point. Well, it's when f of x is 0. So x is negative 2 and 1. The diagram below shows part of the graph of g of x. The tangent to the graph at x equals 2. The straight line perpendicular to the tangent to the graph at x equals 2. The gradient of the tangent, the point A with the coordinates 2, g of 2. So that's this one. Find the coordinates of B. Well, we know y equals 3 minus 4x on 3. When x equals 0, y equals 3. So that's 0, 3. Find the equation of the line that passes through A and C. Okay, so that's g of x. So let's define, that's f of x. Define that as f of x. And we know negative x to the 4 divided by 12 plus x squared on 2 minus 2x on 3 plus 1. Okay, so that's our g of x. Make sure you define it as g of x. Then I would actually go into my graph and table and graph f of x and g of x, graph g of x to make sure it looks right. And then also graph 3 minus, was it 3/4 x? Or 4/3? 4x on 3. Okay, so we want to find the equation to the tangent, the normal at the point 2. So normal at the point 2, hit xy, that's nasty. So we want to go g of x, find the equation to the normal, calculation line normal at the point 2, 3x on 4 minus 7 on 6. Y equals 3x. Hence find the coordinates of C. So C is going to be 0, negative 7 on 6. Find the area of the triangle ABC. Trying to work out the easiest way. Okay, we know that's a right angle. We can find the distance AC and the distance AB. Is there a faster way? We know that value there is 2, so we know the height's 2. What's B minus C? What's the distance from B down to C? So the distance BC is 3 minus negative 7 on 6, which is 4 and 1/6. So that's that length there. And the height we know is 2. So our area is a half times 4 and 1/6 is 25 on 6 times 2, which is just 25 on 6. Hopefully that makes sense. So we found that coordinate, and we found that coordinate, then we found the distance, because that's the base length of the triangle, and that's the height of the triangle. A half times the base length times the height. I think my my maths is correct. Okay. What the hell is D? I missed this bit. So D is parallel to the tangent at A. It intersects. Okay. So first, it's got the same gradient. So we want to know when f of x, or g dash of x, we want to know when g dash of x g of x, we want to know when the gradient equals 4/3, because we know the other ones got a gradient of 4/3. Wow, what? Is that right? Let's go back. Negative 4/3. Bloody hell. I'm like, that's a horrible answer. That seems so wrong. Negative 4/3. Ah, that's better. So x equals negative 1. So, we say g dash of x equals negative 4/3. Therefore, x equals negative 1 or 2. Hence, d is negative 1. And I've got to find g of negative 1 to find out what the coordinates are. 25 on 12. So that's the coordinates. Find the length of AE. That's the easiest way to go about this. AE. Just trying to think if there's a fast way to do this. So we want that length. Find the coordinates of D. That length. It's going to be the same as that length. I can't see an easy way off the top of my head. Nope. Is that the same distance? Huh. I'm not willing to try and work it out. So let's find, there's got to be a fast way, but let's find so we've got the normal, and we know that intersects the other one at 2. So we know A is 2, G of 2. What's G of 2? 1/3. And we know the normal, that's that. Actually, let's find the equation of the tangent at -1. And then see when that's equal to the other graph. The normal at 2. Because we want to know where they intersect. So solve. So 23 on 25. So E is 23 on 25. And then we can sub that back into this equation. -143 on 300. So the distance of AE is the square root of 1/3 plus 143 on 300 squared plus, so I did that minus that, 2 minus 23 on 25 squared. Okay, so square root 1 on 3 minus that squared plus 2 minus 23 on 25 squared, 27 on 20. on 20 units. So hopefully I haven't stuffed that up. So let's check it again. It's a pretty long question. -2 and 1, find the values of x. So we did that, -2 and 1. Find the coordinates of B, 0, 3. Find the coordinates of C. Find the area of the triangle, 25 on 6. D is -125 on 12. That area is 27 on 20, so hopefully I haven't stuffed it up. Okay, a school has a class set, 22 laptops, kept no recharging, although provided each laptop is correctly plugged into the trolley after use, but its battery charges. In particular, a class of 22 students use all laptop batteries fully charged at the start of the lesson. Each student uses and returns, bloody hell, this is long, exactly 1 laptop. The probability that a student does not correctly plug in their laptop is 10%. The correctness of any student's plugging in is independent of the other one's correctness. Determine the probability that at least one of the laptops is not correctly plugged into the trolley at the end of the lesson. So there's 22 laptops. So X is binomial, 22, 10% chance. The probability that at least one greater than or equal to 0, greater than or equal to 1 is, so let's clear all this crap, distribution discrete binom CDF, 1, 22, 22, 0.1. That's really low. Is not correctly plugged in. Okay. Probably the student does not correctly plug in their laptop. Did I just stuff something up? 1. Freaking hell, I'm like, that can't be right. 0.9015. I'm like, it should be pretty high. Okay. A teacher observes that at least one of the laptops is not correctly plugged in. Given this, find the probability that fewer than 5 laptops are not correctly plugged in. So probability that fewer, because it can't equal 2, x is less than 5 given that x is greater than or equal to 1. Which is, if you've got 5 greater than or equal to 1, they intersect for 1 is less than or equal to x, which is less than or equal to 4. Oh, don't know what I was doing then. It's a little bit retarded. The probability that x is greater than or equal to 1. So we've got to go from 1 to 4. .8394 over, was it 0.9015? But we know we use the whole answer. So that divided by that, 0.9311. Okay, the time for which a laptop will work without charging a battery is normally distributed with a mean of 3 hours and 10 minutes and a standard deviation of 6 minutes. Suppose the laptops remain and charging control for 3 hours. Find the product that will stop working by the end of these 3 hours. So we'll say a laptop is normally distributed with a mean of 190 minutes and a standard deviation of 6, say 6 squared. The probability that XL is less than 180 is, so now it's normal, continuous norm CDF. Remember, it's always negative infinity up until 180. Well, that was 6, and 190, 0.0478. Don't forget, they change the bloody decimal places regularly, which is a bit of a pain in the ass. So 0.0478. Okay, a supplier of laptops decides to take a sample of 100 new laptops from a number of different schools. Samples the size of 100 laptops. The population of the mean battery life of 3 hours and 10 minutes and a standard deviation of 6 minutes. P hat is a random. Okay, find the probability that P hat is greater than. So we've got to use binomial distribution. Samples of size 100. So let's call it S for supplier is normally distributed. No, it's not. It's binomially distributed. We've got 100 laptops. The 3 hours and 10 minutes, the standard deviation is 6. Okay, p hat is the random variable, same proportions of the battery life of less than 3 hours. So less than 3 hours is 0.0478. So we want to find the probability that S is greater than or equal to 6, because we times that by 100, given that S is greater than or equal to 5, which is the probability that S is greater than or equal to 6 over the probability that S is greater than or equal to 5. It's binomial because the laptop either has a life less than 3 hours or a life greater than 3 hours. Okay, so this time we've got 100, distribution, continuous, no, discrete, CDF, 6, 100, number of trials is 100. Well, let's say 0.5, but we've got to change that in a second to use this value. So that's 6. That's 5. So 0.3443. Over 5 is 0.5234. Which is equal to that divided by that, 0.6579. No, 3 decimal places, 6579, 658. See what I mean by they changed the decimal places? I don't know why they do it. So that when laptops have regularly been used in a school for 6 months, their battery life is normally distributed, but the mean battery life drops to 3 hours. Also know that only 12% work for more than 3 hours and 10 minutes. Find the standard deviation. Okay, so still not put them in. Okay, so after 6 months, let's say Y. So it's still normally distributed. It's got a mean of 3 hours, so 180, and a standard deviation. We'll call that A squared. The probability that Y is greater than 190 is 12%. So the probability that Z is greater than B, we'll say is 12%. So let's go inverse, and then we'll go to the right, and we'll say 0.12. So that gives us our Z at 1.1750. We know that Z, 1.1750, is equal to X minus mu on sigma. 190 minus 180 on sigma. Sigma is equal to 10 on 1.1750, so therefore sigma equals 10 divided by our answer, 8.51 to 4 decimal places, 8.510 something it was, 8.5107. Oh, that's supposed to be 0.12. Therefore, B is equal to 1.1750. This is a long question. Okay, laptop supplier selects a sample of 100 laptops that have been used for 6 months from a number of different tests of battery life. Estimate. Suppose I turn it one at a time. Find the probability that the first laptop found to have a battery life of less than 3 hours is the third one. So that would mean the first one doesn't have it greater than, so less than 3 hours. Okay, so they've been used for 6 months. Okay, so if the first one doesn't last longer, that's a half. Second one is a half. Third one is also a half, because the mean is 3 hours, which is 1 on 8. Because they give you the order, you just multiply. Laptop suppliers finds that in a particular sample, 6 of them have a battery life of less than 3 hours. Determine the 95 of the supplier's estimate of the proportion for the supplier's estimate of the proportion of interest. What the hell does that mean? Estimate for the proportion of interest. 95% confidence interval. Okay, so 6. Oh, the proportion. Okay, so we know P hat is equal to 6 on 100, which is 3 on 50. But can't we just use, yeah, we can just use 6 out of 100, 95% confidence interval. So we go statistics, calc, interval, 1 sample Z, no, 1 prop Z. I'm used to specialist. 0.95, X is 6, 100, 0.0134, 0.01, and then my upper 0.11. It's a bit stupid. Sorry, needed a drink. Okay, the supplier also provides business laptops to business. For the battery, the probability density function is given below of a number of after 6 months of use. Find them. Okay, so we just want to find the mean of this. So the mean, 210. This is just painful, and I bet the calculator would take a while to do it. So 0 to 210. And then division. 210 minus x. E to the power of x minus 210 on 20. X minus 210 on 20 divided by 400 dx. However, when we want an expected value, we've got to times it by x. 170 point. What the hell is going on? 170.00, wasn't it? 01. Find the median battery life in minutes. Okay, so we'd go from 0 to m, f of x dx equals 1/2. Therefore, n is equal to. So in this case here, we change grab this, we scrap that x because it's no longer multiplying. We say up until, let's say m, and that equals 1/2. Solve for m, 176.45. So m equals 176.45, or 225.36. However, 0 is less than or equal to m, which is less than or equal to 210. So therefore, m is equal to 176.45. I think that's right. Oh, this is the last question, so hopefully it won't take us too long. I bet you it will. Okay, express 2x plus 1 in the form that. Okay, so you can do x plus 2 into 2x plus 1. X's into 2x goes 2. 2x plus 4. When we subtract, -3. Therefore, 2x plus 1 on x plus 2 is equal to 2 minus 3 on x plus 2. Find the rule and domain for the inverse function. Okay, so let y equal f of x, swap x and y. So we get x is equal to 2 minus 3 on y plus 2. Okay, so from here, we get, I'm just trying to think if it's easier to do it the other way. So if I have x equals 2y plus 1 on y plus 2, xy, x, x, bloody hell, xy plus 2y is equal to 2y xy plus 2x is equal to 2y plus 1. So if we bring all of our y's to one side, what are we going to get? Xy minus 2y equals 1 minus 2x. This is just stupid. They don't leave you enough room either. Okay, if we did it this way, x equals 2 minus 3 on y plus 2. X minus 2 is -3 on y plus 2. Y plus 2 is equal to -3 on x minus 2. So we can say f inverse of x is -3 on x minus 2 minus 2. And the domain is x is an element of all reals except for 2. I just was sort of like, what the hell do they want us to do? -3 on x minus 2 minus 2. The domain is all reals except for that. Okay, part of the graphs of f and y equals x are shown below. Find the area of the shaded region. Okay, so it's obviously going to be the 0.11. Let's clear all this crap, and then clear this. So what do we have? 2 minus 3 on x plus 2. 2 minus 3 on x plus 2. Sketch it. And y equals x. Okay, interactive events solve. Let's see where they intersect. -1 and 1. Okay, so let's go back out. I'm going to define that. Copy, paste, define it as f of x, and then we've got to integrate from -1 to 1 f of x, just minus the graph of x dx. That looks like root 2. Nope. -3 log e3 plus 4. So the area, -3 log e3 plus 4. Okay, part of the graph of f and that is shown. Find the area of the shaded region. Well, it's just going to be double the last one, because it's just the same thing, but like that. Okay, so area, -6 log e3 plus 8. Part of the graph below is shown. So that's f of x. PCD is on the graph. Find the exact distance of this point to the origin is a minimum, and find this minimum distance. It's the normal, because it's at right angles. It's the normal that goes through the origin. Okay, so we can say the equation of the normal at C is so we can go copy. Okay, yeah. So we can go find the equation of the normal at the point C. And that's got to go through the point 0, 0. So say equals 0 given x equals 0. Select all, solve for C. If this doesn't work, there's got to be another way that will make it easier. Okay, so C equals negative root 3 minus 2, negative root 3 plus 2. Must pass through the origin. Therefore, C equals negative root 3. Hang on. Root 3 minus 2. That's negative. Yeah, because it's between negative a half and a half. So C is negative 2 plus or minus root 3. However, c is greater than negative a half. Therefore, c is equal to root 3 minus 2. So if c is equal to root 3 minus 2, then f of root 3 minus 2 so d is negative root 3 plus 2, and the distance is that, because it's with the origin, with the distance formula, we don't need to do minus 0. We can just do that squared. So that minus 0, that minus 0, and then square rooted. So I get 2 root 2 minus root 6. 2 root 2 minus root 6. So that's a distance, because the shortest distance between a point and a curve is always when they're at right angles. Okay, show that x1 is less than x2 implies g of x1 is less than x2. So g of x1 would be k of x1 plus 1 on x1 plus k. G of x2 is equal to k of x2 plus 1 on x2 plus k. So therefore, kx1 plus 1 on x1 plus k has to be less than kx2 plus 1 on x2 plus k. So kx1 plus 1 times x2 plus k has to be less than kx2 plus 1 x1 plus k. So k x1 x2 plus k squared x1 plus x2 plus k has to be less than k x1 x2 plus k squared x2 plus x1 plus k. So that cancels with that. K squared x1 x2 x1 x2, that cancels with that. What can we do here? K squared x1 minus k squared x2 is less than x1 minus x2. Does it make more sense to bring out x1s over to one side? So k squared x1 minus x1 is equal to k squared x2 minus x2. x1, k squared minus 1 is less than x2, k squared minus 1. Therefore, x1 is always less than x2, as k squared minus 1 is always if k was to equal k and you put that in, that would flip it around. -1. The other thing you could do is show that it's always strictly increasing. So kx plus 1, kx plus 1 on x plus k. So there's k times x plus 1 on x plus k diff k must be defined. Okay, so you got k squared minus 1 on x plus k squared. G dash of x equals k squared minus 1 on x plus k squared. There it is. K is always greater than 1. I was looking at this. Bloody hell. If k is greater than 1, k squared minus 1 will be greater than or equal to 0 for all k, and x plus k squared will be greater than or equal to 0 for all k. Therefore, g of x is strictly increasing. So, x1 is less than x2 implies g of x1 is always less than g of x2. Let x be the point of intersection of the graph of g of x and negative x. Find the coordinate of x in terms of x and k. So let's define that as g of x, and then let that equal negative x. Solve. Okay, so negative k plus or minus. So g of x, negative x, therefore x equals negative k plus or minus the square root of k squared minus 1, was it? Plus or minus. Now, because we want it to be, what do we want it to be? Do we want it to be the negative or the positive? What's the domain? So if k is greater than 1, So g of x given k. I want this graph to be negative x. So does it still have to be between negative a half? Okay. Because the g is from negative k to infinity, it can't be negative negative because then it would make it go the wrong way. So therefore, x is the point negative k plus root k squared minus 1, comma, we've got to find g of that point. So g of that one. Bloody hell. Simplify. K minus root k squared minus 1. That makes sense. Because if you go back up here, see here, they're the same thing but switched positives and negatives. We've done the same here. Find the value of k, for which the coordinates are negative a half and a half. So let that equal a half. Oops, I want to solve for k. Not zk, just k. K equals 514. So negative k plus root k squared minus 1 is negative a half, and k minus root k squared minus 1 equals positive a half. K equals 514. Okay, let z be negative 1, x. Let sk be the square of the area of the triangle xyz. Find the values of k such that s of k is greater than 1. X be the vertices of the triangle xyz. Okay, so we know the coordinates of that point. So we can find the distance. So this distance, if you think about it, that's 2 and that's 2. So the base length has to be 2 squared plus 2 squared. So the area, that length there, zy, is 2 squared plus 2 squared, which is root 8, which is 2 root 2. And then the length ox is that. Bracket it. Squared plus my y of a squared. Okay, so that's, come back, you stupid bloody thing. Let SK be the square of the area of the triangle. So that length is the square root of that. So we'll just leave it like that because it's the square of that. 2 k minus root k squared minus 1 squared. Change back, you stupid thing. So we've got the length OX is the square root of 2 k squared k minus k squared minus 1 squared. K minus k squared minus 1 squared. So the area of SK is a half times 2 root 2 times root 2 k minus root k squared minus 1 squared, all squared. Okay, so they cancel. I've got root 2 squared, which is 2. I've got that squared, which is 2. And then I've got k minus root k squared minus 1 squared. So it's 4 k minus root k squared minus 1 squared. I want to know when that's greater than 1. So we want to do that, but with a 4 is greater than or equal to 1. Greater than 1. Equal to 1. Wow, I'm trying to solve for bloody k. Not k. I want k. Okay, so k can't be less than negative 1. So 1 is less than or equal to k, which is less than 5 and 4. Therefore, 1 is less than... Is that what it was? Bloody iPad's pissing me off. 1 is less than or equal to k, which is less than 5 and 4. Okay. Okay, we're nearly there, thank God. Okay. The graph of G and the line y enclosed in a regional plane below, shown in the diagram below. Let A of k be the rule of A gives the area of this region. The domain of A is 1 to infinity. Give the rule for A of k. Isn't it just negative 1 to 1? Is it g of x? The hell is our function called now? G of x minus x dx. So a of k, negative 1 to 1, g of x minus x dx. So negative 1 to 1, g of x minus x dx. Bloody hell. Okay. So 1 minus k squared log e of k plus 1 on k minus 1. Plus 2k. Okay, so that area when k is greater than 1. So there's k. So let's zoom in. We'll go from negative 1.2 to 1.2. Zoom auto. We want this graph to be x now, not negative x. Okay, so let's see what happens as k increases. That area gets smaller, so it approaches 0. Oh, oops, stop. What about as k? Let's go from 0. Does k have to be? It has to be greater than or equal to negative 1. If k is greater than 1, okay, so let's see. If we start at 1 and go up by 0.1, so you can see that if k, let's go back to this, if it was 0.001 and we start at 1, see that's nearly a square. So this thing here, that area is nearly 2. So as k approaches 1, a of k, how do we do this? So basically what I'm saying is, if you sketch that graph, and if you sketch the other graph, as k is really small, this basically becomes like a square. And we know that there is negative 1, that there is 1, and this here, if we were to draw a square, that would be 2 by 2. So this bit here, if the square area is 4, therefore the triangle is 2. So if k approaches not 0, as k approaches 1 from the positive side, a of k approaches 2. If k approaches infinity, a of k approaches 0. So therefore, 0, if k is greater than 1, 0 is less than a of k, which is less than 2. Does that make sense? So as k goes to 0, k goes to 1, that approaches 2. And as k goes to infinity, the area approaches 0, but it never actually get to 0. How would you do that algebraically? Yeah, so basically that area is going to approach 0, and this area of this triangle, area of the triangle equals 2. So it's got to be bound by the triangle, which is 2, and then the other one is if you've got that line and then your curve is basically flat, the area is 0. I reckon they would have been pretty lenient with that one, but this makes sense. So yeah, I can see why a few kids found that pretty hard. Hopefully that makes sense, and hopefully I haven't stuffed anything up. Good luck with it. I'll catch you later. Don't forget to like, share, subscribe, turn on notifications, blah, blah, blah. Bye.